we're doing general solution for trig functions. Now, if I ask one of you, pick up a value of cos, which is your favorite. Can you pick up a pi by, what is cos pi by 4? Can you just give that to me, please? Like, what is cos pi by 4?
Root 2 over 2.
Root 2 over 2, root 2 over 2, which is nothing on 1 over root 2, right? Now, keep that in mind, okay? Now, if I ask you to, okay, solve uh, cos x equals to root 1 over root 2. So what is going to happen? So if I write it like this, say let cos x be 1 over root 2. And I ask you to solve for x. So what are the possible values where that I can solve? Let's do the anti-clockwise rotation, right? Anti-clockwise rotation is ASTC, and obviously this is across, that's anti-clockwise, clockwise. Now, cos, I need cos value to be a positive value. That means I'm after first quadrant and fourth quadrant value, right? And in the world of anti-clockwise rotation, this is theta, this is pi minus theta, this is pi plus theta, and this is 2 pi minus theta. My theta value, the reference angle, is pi on 4. And my second value would be 2 pi take away pi on 4, which is 7 pi on 4. So now I got x equals to pi on 4 and 7 pi on 4. Let me do a negative rotation now and try to see, because I'm not given anything in terms of domain. I can go on the either side. I can go clockwise, I can go anti-clockwise, which means that the wave is like this. I can go here or I can go here. So this side is the clockwise rotation. This side is this is the anti-clockwise rotation, and this is the clockwise rotation. Now if I do this rotation like this, what are my values? Negative theta, negative pi plus theta, negative pi minus theta, and negative 2 pi plus theta. Correct? Right? If I remember correctly on top of my head. Correct me if I'm wrong. So ASTC still stands true here. And I'm still after first quadrant and fourth quadrant. My reference angle was pi on 4. Hang on. So I've got negative theta here. So negative pi on 4 is also one of my choices. And then I have the first quadrant, which is negative 2 pi plus pi on 4, which is negative 7 pi on 4. So this was the anti-clockwise rotation. This one is the clockwise rotation, right? Now, how do I get my other solutions? I just keep adding 2 pi. In here, I'm just adding 2 pi to get to the next point. And in here, I keep subtracting 2 pi's to go to the next point, right? So if I just do the same thing here, pi on 4 plus comma 7 pi on 4, let me just add 2 pi, pi on 4 plus 2 pi, 7 pi on 4 plus 2 pi. This becomes x pi on 4, 7 pi on 4. This becomes 8, 9 pi on 4. And this becomes 8 and 8, 16, 15 pi on 4. Right? And on the other side, I will get the negative values across this. So you will start to see a pattern. You will start to see a pattern of 2 pi's. Because I'm playing around with 2 pi's on both the sides. How do I get to the next point? Just, it's a multiple of 2 pi's that I'm skipping. Getting my point? So, I'm just adding 2 pi's. So if I'm here, I'm adding 2 pi to get to the next point. If I'm here, I'm adding 2 pi to get to the next point. Similarly, it will be on the other side as well. So if I minus pi on 4, minus 7 pi on 4, right? You keep subtracting. It's still a multiple of 2 pi's. So I can now generalize this, that I've seen a pattern that, okay, if I find my first reference values, which were pi on 4 and 7 pi on 4, the rest is easy. I just add 2 pi's on left or right, and I get every possible solution that I need. So now Kaz generalizes all of that. And Kaz says, okay, now if you want to know the general solution of cos x equals to a could be any value, where a obviously has to be between -1 to 1 because that's the minimum and maximum for cos. The generic solution, if you don't give me the domain, me is the Kaz. If you don't provide Kaz a domain, I will throw you a generic solution. And generic solution is a multiple of 2 pi's, is not the multiple. I'm just adding 2 pi's to get to the next point. So I will give you x equals to 2n pi. Now 2 pi, n is critical. Either you add or you subtract cos inverse a, the first value, pi on 4, or 7 pi on 4. You get 2 points, 2 values of this stuff. And you keep adding. If you keep adding, I move to the right. If you can subtract, I move to the left. Let's give it a go. So my solution was 2n pi plus minus cos inverse, and I was given 1 over root 2. What was this? This was 2 values, pi on 4 and 7 pi on 4. Let me put pi on 4 here first. So I have 2n pi plus minus pi on 4. And the other one could be 2n pi plus minus 7 pi on 4. What is n? That's the last question of the puzzle. N belongs to integers. N is an integer value. Integer means you can go from 0, 1, 2, 3, 4, 5, 6 whole numbers, and -1, -2, -3, -4, -5 until negative infinity. So if I plug in, let's say n equals to 0 here and n equals to 0 here, what do I get? N equals to 0 mean all of this is gone, and this is gone as well. You get your first rotation clockwise, anti-clockwise value, which we found here. Let me plug in n equals to 1. 2 times 1 pi plus pi on 4 and 2 times 1 pi plus 7 pi on 4. What do I get? 2 pi plus pi on 4, which is 9 pi on 4, and 2 pi plus 7 pi on 4, which is 15 pi on 4. And look at what we got here. That's what we got. Change the color of my pen. That's precisely what I got. This pair was n equals to, this pair was n equals to 1. This pair was n equals to 0. And I can, let's see, this was my first clockwise rotation. What do I do with this? How do I get this? I go down, I say, okay, and I change the color here. It was 2n pi. I've taken a plus here, now I take a minus, because I'm going in the left-hand side of the graph, which is I'm going here. I'm going here. Right? So this will be n equals to 0 means all of this is 0. You get negative pi on 4, the value that we got. And the other one was 2n pi minus 7 pi on 4. Plug n equals to 0, you get negative 7 pi on 4. That's precisely what we got here. And that is why CAS throws you a generic value, a generic solution for cos. It says keep jumping by 2n pi's. Thus, if you want to go into the right side of the graph or anti-clockwise rotation, but please keep adding the inverse and keep subtracting if you want to go on the left hand side. This is anti-clockwise rotation. This is clockwise rotation. And I just combine them to say this. Finish. Exactly the same scenario is for sine, and exactly the same scenario is for tan. Generic solution could be slightly different because pattern identification is slightly different. Cos jumps by 2n pi, sine is slightly different. Sine jumps by 2n pi and 2n plus 1 pi. Again, plus sine inverse A. This is minus sine inverse. And there is a reason behind it. Why? Why we do 2n pi for sine and 2n plus 1 and just do 2n pi for cos? Simply because of the quadrant. Sine, I need to identify first and second quadrant. So that is why I have two different patterns. Cos is first quadrant and fourth quadrant, which is roughly 2 pi rotation almost. And that is why I only have 2 pi. And tan is, the period of tan is pi. So tan is even more simpler. So if you have tan x equals to a, so x equals to generic solution will be n pi. Why? Because now the period of tan is pi. So if you've got the first value of tan, first rotation value, the next rotation value, you need to add pi's to it rather than two pi's. Because tan is pi on n. The period is pi on n. So therefore, there's no 2n there. And you simply say plus tan inverse of A. So all these generic solutions is nothing but pattern identification of your solution. That's about it. Just identification of the pattern. Nothing more, nothing less. So if you don't specify the domain, you get generic solution. Am I clear?